involved files and the problem. From that information, in itself is of great importance because, as Gaston was saying, much of the time in software development is involved to maintenance, and in particular, related in the time related to bug fixing. There's a lot of work on what files to look at, determining where to put a breakpoint, etc., etc. So if we can resolve this, it not only saves a lot of time, but it also facilitates the work for junior developers, or even for developers with more expertise, but maybe which are not familiar with a specific repository. So on the second stage of the code fixer work, it takes that diagnosis and thus produce a fix and applies it to the working copy. So developer can then go on and check the proposal, refine it, commit, etc., etc. Okay, code fixer offers three main interaction interfaces. The first one is a command line execution that is the one actually used to run for the benches. This command line execution allows the user to present a list of tickets, a batch, and receive the diagnosis and fixes for all of them. There's also a web browser UI on which the user can see the list of tickets, select one of them, check the details, ask for a diagnostics. There's also a chat. The user can chat to refine the diagnostic, ask for a fixed proposal, refine, etc., etc. And this same interaction can also be done on a chat that works directly on a command line terminal, which in fact resulted as the preferred method of interaction for most of us, because, for example, you are in VS Code working on your code, and right there inside VS Code, you can have a terminal window on which you start a chat with code fixer. So you can say, I don't know, what tickets are there? What about ticket 42? Can you diagnose it? And code fixer answers and executes actions from what you ask and what you ask the code fixer to do. Okay. And finally, it still is a work in progress, but we are working on creating integrations with VS Code, with GitHub, Copilot, etc. So you don't need to go outside of your usual processes and tools, and can access code fixer directly from there. So now, Marcelo, go ahead and do your show.
Okay, hi, I'm Marcelo. I am a research engineer from the Code Fixer team. I will be walking through a little bit on the SWE-Bench, then our agents, how they work, and then we will be going over our experience with autogen. First of all, SWE-Bench is the leading benchmark on software development tasks, and it's our primary way to measure the performance of our agents. It is made up of real-world tasks, issues taken from GitHub, from open source repositories, and it tries to measure up to what point are agents capable of solving real-world issues. It has some limitations. For example, it's over-specified in Python backend tasks, but nevertheless, it has proven to be very helpful to be able to measure very easily how our agents are doing with real tasks. So the input, as Jose was showing, it's in an issue and a code base. And then the language model or the agents are tasked with modifying the code base and fixing the the bug or the issue. So our code fixer AI logic is divided into two steps or two stages. In the first one, the fault localization stage receives the issue description and the code base and outputs a list of candidate files and a localization report. Then our fix stage goes on to provide a solution to the bug and implement it. And in the localization step, we have a single agent, and in the bug fixing, we have 3 agents collaborating. Now we'll dive deeper in them. Here we can see some of our previous versions where we quickly iterated into trying to improve our performance in localization first, and we achieved almost perfect performance. One of the special things we made in version 2, we added autogen that added robustness and maintainability to our code. And then we went on to iterating on the fix stage, and we eventually achieved state-of-the-art performance with almost half of the tickets sold in the SWE-Bench Lite at a budget below $1 average, and also about 2 minutes time to run each ticket, which is, we think, a very good very good timing, because it makes the tool very approachable for users. For example, some of the other agents that we see in this leaderboard, some take up to half an hour or 1 hour to run, and that's why our solution, we think it's also very useful. Going into the localization stage, the localization agent uses available tools to get to know and search through the code base until it detects or it thinks it found the candidate files, and it provides our localization report. We can see in the diagram, we have a user proxy which starts and finishes the conversation, a code executor agent which executes the tools. But the actual LLM-based agent is our code analyst agent, which does most of the intelligent part. And then in our fixed stage, we have 3 agents collaborating to propose and implement code fixes iteratively. First, our architect agent proposes a solution to the bug. Then our editor agent uses an addition tool to edit the code base and solve the issue, implementing the bug fix proposed by the architect. And then we have a critic agent which evaluates the implemented patch and decides whether it's good enough or we need to continue iterating, in which case it gives some feedback to the architect to tell him why it wasn't good enough. And we go on to iterate until we arrive to a good solution. So finally, some remarks on our experience using autogen as a framework. Some of the things we most liked is being able, it's having a robust conceptual modeling and built-in conversation patterns like nested group chats. Then we also like the multi-language implementation of the framework. And some things we think would be nice to see a little bit improved are, we have dealt with some issues with hard-coded strings. For example, the terminate string that decides whether an agent run finishes. We have had some problems with that. Also about observing agent communications. It is hard to track interactions sometimes. And also about memory management, we've been looking for ways to easily handle context and memory during long interactions, but this remains a complex issue. And also, I would like to say that the plug and play idea with conversation patterns, although it's very good idea, we found that implementing conversation patterns isn't as plug and play as we expected. And we've also went on to customize some things from the framework. We customized the activity report stream because we wanted to improve logging and monitoring. And also this is part of our front end, let's say. The user gets to see this activity report, so we had to polish it a little bit. And then we also used a custom LLM client in order to support Globant Enterprise AI, which Gaston and Jose were talking about before. So here are some useful links that I can send through the chat later. But just to summarize, we've been using autogen to build top performance software maintenance and bug fixing agent that also keep time and cost low. And we've built all this with autogen, so we're very happy to be here. We're very happy to answer any questions. And also I can go on to give a little demo if you want.
Yeah, first the demo, Marcelo.
Yes.
First the demo, and after we go to the questions.
I'll stop sharing for minutes.
You are mute, Marcelo. No.
Oh. There, can you hear me? I open up the app and
You still mute. Is the problem that we have today with the mute and microphones?
Are you sure?
No, you're not on mute, Marcel. You're quite audible.
Okay. Yes, I think maybe Gaston, you have the volume down. So okay, I'm ready. I can share the code fixer. There, can you see? Here we have our front end. It's one of the ways to access the app, as Jose was telling. We have here a list of bags. I have loaded some SWE-Bench bags, and we can get into one of them. Let's say this one. It has a syntax error given some case condition. So we can go on and try to diagnose this. So here we will be seeing what the agent does. It starts calling tools until it gets into until it considers it has found the candidate files. So let's let it run for a minute. Let's see. Well, it will take a minute, but we can see that it has started by detecting language and dependencies. Then it has made a search. It has searched for count aggregate. Then it's found something. It tries to read a file where it found something. And I think it's about to finish. This is the localization step. we actually have the two parts separated in our front end too, mainly because we have an almost perfect performance in localization. So that's very high probability of being a useful input for the user. So we think that only running the diagnosis is already a very good thing for the user. And well, I think something is not working very correctly. It's kind of stopped. Let me see if I have some other ticket to run. Okay, I think I might have a not updated UI version or something, because I think the fixed run, but I didn't get the proper like change in the UI. But here is the diagnosis. So this was our initial ticket, the localization step run, and we got a diagnosis report where this is all useful information for the user. And the most useful is the files where the bug is located. And then we can go on to fix the bug. Here we'll have our architect, our editor, and our critic collaborating to make a patch and fix the issue. So let's see what the architect says. I'm actually, I think I'm using a develop version, and it's not actually outputting everything it should output. Here we should see architect output. Sorry about the issue, but here we can see the editor is using this apply diff tool, where it gives the tool an original code and a new code with which to replace it. Then the editor says there's a success state, and the code critic is the last one to go. Final state success. Okay, nice. So now the issue is fixed. And here we can see the proposed patch for the issue. So we have the original ticket, the ticket diagnosis, and the fixed stage. And sorry about the logs in the middle, because they I think I have a incorrect version and they didn't output correctly, but that's what happens in demos. So right, any questions? We'll be happy to answer them.
Thank you very much for the wonderful talk. Really enjoyed it. Feel free to raise your hand from audience to ask questions and unmute yourself to directly ask. And before that, I can also read. Before we see any hands raised, I can read some of the questions from the chat. Okay, let's get started. And by the way, Shaokun, please make sure you give the audience permission to like raise hands and unmute themselves.
Yeah,
okay.
Every audience should have the permission to directly, to unmute themselves and raise hands.
Yeah. yeah, I think some of the questions have been answered in the chat, but it may be also good to repeat that. So, okay, the question, can you expand on a question from Calvin Smith? Can you expand on how AG2 simplified chat memory handling impact the development of code fixer?
Okay, yes. Actually, we kind of handled some of the memory things by ourselves. So we there's a I don't know. Sorry, I read some messages. So we are sometimes extracting things from one agent and sending them to the other one in a customized way. That's because we have some issues with previous versions of chat history where we didn't quite get to the very useful use of the provided structures. So I think we kind of don't use the most elaborate memory handling things from AG2. We kind of make much of that customized.
Yeah, thank you. And Kevin, if you want to unmute yourself, direct ask, feel free to raise your hand and unmute. Another question from Kelsey Conoffy. I'm noticing in many multi-agent systems, most of the agents mimic human developer roles on standard development teams, like architect, implementer, reviewer, etc. Have you found situations where new agents that break from the traditional software engineering development team model that have added value?
Well, yes, there's been a lot of work into trying to mimic the how we work as developers. I think that has been some of our guiding principles in trying to give the tools, the agent, the tools that it needs to be able to perform how a human would. Also, there are some single agent solutions that have been very interesting. We have been trying that out too. But we believe trying to mimic human work is kind of very useful, and then you have to go and see where the mimicking is not working. And for example, in the editing phase, we found that there are a lot of issues, and we have iterated through many versions of the code edition. And so I don't know, maybe the human mimicking is a good principle to start with, and then you have to see how that mimicking went on, and if it really did it correctly, or there are some agent issues which you have to fix in some way.
Yeah. Thanks. Next question from Marcos Mercedo Constrera. Do you have any numbers or anecdotes on the impact of this tool on your customers? Is this being used in production or still under development? How are they using it?
I can take that. Sorry again. It's an echo. No more in different room next time. Sorry. Well, we started using internally in many projects. We don't have figures yet. We try to use, actually 50% is still low. It's still low for real world for the real world. So what we have been doing internally is to use the concept of the full localization is quite better. So we start, because here is not only try to use a new tool to try to change many processes in some cases. So the short answer is that we don't have figures yet. We are trying to have this kind of figures. It's not so simple because actually in some cases we need to change how we are going to work. For example, in some cases we are using the batch process in order to have the localization stuff, the full localization, and add this to the Jira ticket, for example. So we add productivity in terms of full localization and have like 4 options. We are trying to put this in the product of saying, okay, I will give you like mid-journey generate 4 images. We can give you 4 possible solutions, and we are working on a taxonomy of kind of errors where we know that in some kind of error we are our percentage or our accuracy is, I don't know, 80%. So we are giving you this hint that we are helping you and with some level of confidence. Okay, so we are using yes in production, helping the people, helping our people to solve the real world problems. For some kind of issues is not working well. For example, for UI, for some part of our taxonomy, say the kind of ticket is for UI is not working so well, but for exception handling is working quite well. So first of all, we are trying to add all these things in our product for doing. Actually, our first version internally, we released internally in, I don't know exactly, but it was April or something like that. So we have several several fails on using. Okay, and now we start feeling that there is something here. Okay, that there is something that if you start from the beginning using this, you are going to have productivity, and we need to change our mind on how to several processes we are doing in the past. For young people, it's easier. Say, okay, yes, what is my new editor? What is cursor? Where are my agents? Where are my agents? So for this and this is just, I think that it's something that is here to be used at different levels. But yeah, there's not a final answer right now to this. But we are going to continue working and bring the figures to the market because we are measuring that, and let's see.
Thanks. Next question from Isaac. Does the system go through the code base to find the flow of the required fix, like imports, etc., figure out all the files it needs context from before writing any code, or does it write code from the issue string provided by SWE-Bench and test it to figure out what it needs?
No, actually, the localization step gets the agents to go through all the files before actually making any real changes to the repo. So yes, the system goes through the code base first and then implements the change.
Yeah, thanks. And from David, Giordano, I read your paper. Congratulations on the ideas around localization and code fixes. Do you plan to release these tools as open source?
Maybe Gaston, do you want to?
At this stage, no. We are not thinking at this stage to release this open source. Actually, as you said, and many in the chat are seeing, the actual solution is quite simple in terms of what we did with autogen. Right now, we need to focus at this stage on try to collaborate on papers. Actually, this paper that I'm talking about, taxonomy, etc., we are going to release it, and we are going to give our insights. we don't feel that we have a secret sauce here. The full market is here solving this kind of problems, and actually the techniques that we are using are open already, and many things that we did are very hard code, and like the activity stream, etc. Probably we would like to collaborate with AG2, where, for example, for things like these things that we did, that we use, and we feel that the framework itself for generic systems, generic agentic system, what we did is helpful for all the community. Yes, we are going to collaborate with the AG2 probably, for any, as we did with many products in the past. At least we are from Genexus, and we have several. Actually, all the UI that we create, all the controls are open source and can be used. It's a Chameleon library, that is open source, because we feel that for creating UI, we can help on that. So the short answer is not. We are not going to open source at this stage. We are focusing on data science, in the data, in the how to solve the final problem, and after we can see it. It's not discard, obviously, but we need a lot of things to actually to do in trying to solve the problems in each stage: code generation, fixing, etc. And yeah, we will feel that probably in next month we are not going to be the top scorers. Probably that's another ones, because this is going to be a moving arena. But yeah, we want to collaborate with AG2. We are here to collaborate with any of you. And yeah, we are probably all the things that we can collaborate with AG2. We are going to put as collaborator in the repo of AG2.
Fantastic. I'm really looking forward to the collaboration. Next question from Jose Luis Latour. How does it fare compared with both Devin, Open Devin, and similar? Should be an easy question. Yeah.
Well, good question. Comparing with OpenDevin, it's easy to compare because they have an SWE-Bench submission, just like we do, and we did a little bit better than them. We have better performance and also quite lower time and budget. Then comparing to Devin, it's complicated because Devin doesn't get their bench results open, so we don't know what it does in this bench, and the same with Bolt. But I think these tools will maybe try to get some different ways of getting into users. Like, for example, Devin, it tries to be very autonomous. We try to give a little bit more of the tooling to the human user and make it more useful for him if he wants to make the code fixer do different things. But well, I don't know. I would say our solution is a bit better than OpenDevin, and the other ones we are not so sure, but probably very, very similar.
Yeah, thank you very much. And there are several questions that are similar or related to each other. One is from, sorry, the chat window keeps refreshing. It's from Michael John Cafarella. What features would you like to add to AG2 to make it easier to build? And another related question is, 1 second. Do you have from Peter Francis, do you have a more detailed architecture diagram somewhere showing your tool stack? Very interesting to see what you've used to augment your AG2 implementation.
The diagrams we have, it's actually the ones we showed here and in the white paper that I shared in the chat. So you can see something similar. We don't have more low-level diagrams to share, sorry. And then about AG autogen or AG2 improvements, maybe some of the things we talked about that we would like to see some things a little bit better handled, like termination strings and that sort of thing. Also, maybe better memory handling, and also we would like to see a easier way to implement communication patterns. I think that are some things we would very much like to see in future versions.
Yeah, I'm happy to follow up on those improvements. Yeah, so happy to discuss. And also for others who haven't checked the latest release of AG2, there are quite a few new features that partially address some of the problems. Next question from Jose Luis Lato. Did you explore any particular prompt engineering technique tailored to agents, which is particularly useful, successful? If so, which?
Yes, we have been working with many prompting techniques. For example, chain of thought, where our critique agent has a very elaborate chain of thought technique, which we also had to modify to be able to support our models like O1, because now with O1, chain of thought isn't actually a very good idea. You have to leave it do its own chain of thought. Not try to force it into a structure. So yes, we've been using prompting techniques, not something like many things that are already common knowledge. I think we have also found much use in optimizing workflows, not just prompts, but also getting different agents for different things and getting the flows to work correctly. That has been very important for us too.
Awesome.
I don't know.
Yeah. I think we're over time. I want to read one comment from Sebastian Gomez. It would be awesome having this as a GitHub agent, like dependent bot. Great job, guys. Look forward to what you do next. Really appreciate your wonderful talk, excellent talk, and also appreciate all the questions from the audience. Thanks the speakers again. So I see there are still questions upcoming, but I don't want to take too much of the time of the speakers. If you want to share any kind of follow-up, like contact, maybe you can follow up on Discord in our community or other ways you prefer. Thank you again, everyone.
Thank you so much.
Thank you.
Bye.
Nice being here. Bye bye.
Thank you.